Okay, this is for problems 30 through 35. I left some of the work I did on the previous one, or the subsequent one, whichever way you look at it, on the board, so we've already done a lot of the heavy lifting. This is your scratch paper. This is again an A, B, C, D, E problem. And the question is, indicate the hybridization of the central atom in the following molecules. It can either be A, sp, B, sp2, C, sp3, D, sp3d, and E, sp3d2. Those are your options. Okay? Now, the first molecule I have here is beryllium dichloride. This one is not on our list, but we can, I'll do it over here. Actually, yeah, that's it. Because it's one of the early ones. This is more of a salt. I have got how many E pairs on the central atom? 2, right? Okay, and I have no lone pairs on the central atom. So, what have I got? SP. So that would be A. For, what's this molecule called again? Perchlorate. Do we have perchlorate? We have it right here. What kind of E pair geometry is there? It's tetrahedral E pair geometry, which requires what kind of orbital hybridization? sp3, which is option C. Okay, number 32.
Well, question.
Yes.
So beryllium is fine with just the 2 pairs?
Yeah.
Okay.
Yeah. Actually, it's going to be a heck of a Lewis acid. It's going to form. We won't get into that detail. It's going to form. Actually, they're going to line up like this.
You don't have to explain it.
I won't explain it. It's a Lewis acid base adduct, and it's going to form this big long chain of them. The chloride ions from the lone pair electrons on the chlorine donating 2, and 2 of those. So it's actually going to be completed. Yes.
Are there any more that will be
For that, I'm not likely to give you any more. It would have been, the other possibilities would have been for the Lewis acids, would have been the electron deficient compounds of group 3. That would have been more appropriate. This one is a little more complicated. I just needed a linear example for the test, and I probably will avoid things like that on the test.
So you said it's going to be from column 3?
What?
You're not going to do any like strands like that, it's going to be from column 3?
I mean, not problem
You're not going to
3.
do Lewis.
Group 3.
I'm sorry, group 3. Yeah.
Group 3 would be the ones that would be electron deficient. I would expect you to know that, because we covered it.
Yeah.
And what is so special about having only 6 electrons? What does that give it? A filled subshell, yeah. So that 6 electron would be maybe stable on that basis. It's just a theme. Okay. Having said that, we've already answered perchlorate because we drew it. We had it in our scratch paper. But it's tetrahedral E pair geometry that requires sp3 hybridization. We've done that one. SO3, where do we draw that? Oh, here's SO3 over here. Again, it's on our scratch paper. That's why I'm going to repeat so many of these on the test, because you only have to do the work once, or as few times as possible. We have only a couple hours for the test. This has trigonal planar E pair geometry. And therefore it has what kind of hybridization? sp2, which is B. Now we have, what's this ion called again? The what? Chloride. Here, here's a chloride over here. Again, what kind of E-pair geometry? And the necessity for drawing it arises because the E-pair geometry is different than the molecular geometry. It's tetrahedral again. So it's going to be sp3, which is option C. Now I've got another one that I'm going to have to draw, antimony pentafluoride, which is going to get, let's get there. Okay, what group is antimony? Group 5. So I have 5 plus 1, 2, 3, 4, 5 times 7, which is 35, equals 40 electrons. I deduct minus 10 electrons. That gives me 30 remaining. How many do I need for each of the fluorines? 6. So that's going to take up 30 electrons. I have no lone pairs in the central atom. At the very least, you're going to need to carry it that far. That would require what type of E-pair geometry? How many E-pairs around the central atoms? 5. What type of E-pair geometry does that give you? Trigonal bipyramidal. Trigonal bipyramidal, which requires what kind of hybridization? Okay, so that would be number D. And just for laughs, we'll draw this one. Okay, and now last is tellurium hexafluoride. Okay, again, what group is tellurium? Group 6. Okay, and so I have 1, 2, 3, 4, 5, 6 times 7, which is 42. So 6 times 7 plus 6, 42 equals 48 electrons. And I have 1, 2, 3, 4, 5, 6. 6 times 2 is 12 minus 12 electrons requires that I have 36 electrons remaining. I pretty much answered all the questions I need to here. I need 6 more on each of the fluorines. There are no lone pairs on the central atom. I'm going to have how many pairs associated with the central atom? Which requires what kind of E-pair geometry? Octahedral, which requires what kind of hybridization?
sp3d2.
So that is option E. And I'll just draw it for laughs. I don't know if it's going to come up again or not. Okay. And that answers that series. Any questions? Great. Let's move on.